Welcome to Chapter 4 of my series on my personal exploration with squircles. In this video, we'll define base p trig values on the unit squircle. By the end of this video, we'll have created a figure like this. At the angles 0, pi over 6, pi over 4, pi over 3, and pi over 2 radians, we'll know the xy coordinate pair cosine base p and sine base p for each angle. Let's start with the easiest one first, sine base p of 0. We'll break down sine base p into height base p and sine. Since sine of 0 is 0, by the zero product property, sine base p of 0 is 0. For sine base p of pi over 6, we'll plug in the unit circle values. Then simplifying the fractions under the negative pth root, you get 3 to the p over 2 plus 1 over 2 to the p, all to the negative 1 over p times 1/2. If we take that 2 to the p out from under the negative pth root, it will cancel with the 1/2, and we arrive at sine base p of pi over 6 equals 3 to the p over 2 plus 1, all to the negative 1 over p. Next, sine base p of pi over 4. All the height terms are root 2 over 2, also known as 2 to the negative 1/2, so we can consolidate them. In this form, we can distribute the negative pth root and finish by summing the exponents. So sine base p of pi over 4 equals 2 to the negative 1 over p. The process for pi over 3 is similar to pi over 6, since height of pi over 3 equals height of pi over 6 due to its reflectivity. We know that the 2's eventually cancel each other out, so now we can move the root 3 under the negative pth root by multiplying the exponent by negative p. Then, distributing that 3 to the negative p over 2, we get that sine base p of pi over 3 equals 1 plus 3 to the negative p over 2, all to the negative 1 over p, which is also equal to sine base p of pi over 6 times root 3. And finally, another easy one, sine base p of pi over 2. Height base p of pi over 2 is 1, and sine of pi over 2 is 1, so sine base p of pi over 2 is 1. Great! So these are our first quadrant unit squircle values for sine base p. I like to note that there are many ways to derive the unit squircle values. Here I chose to demonstrate that it's possible to derive all of them through arithmetic. Another method you could use is using the Pythagorean identities. You'd only have to directly calculate the values for 0, pi over 6, and pi over 4 that way. Anyway, we have a problem. We only have unit squircle values for sine and not cosine. Luckily, since height is reflective over pi over 4, we can match sine base p of 0 with cosine base p of pi over 2, sine of pi over 6 with pi over 3, pi over 4 with pi over 4, and so on. Thus, our first quadrant unit squircle is completed. Take a good look at this guy because I think he's pretty cool. We came up with surprisingly simple expressions for coordinates on a unit squircle. And completing the entire unit squircle is not much of a task due to a squircle having 8-fold symmetry. Behold the unit squircle in all of its glory. Okay, moving on. The final thing I want to note is that because of the form of these unit squircle values, it makes the reciprocal trig functions so much easier to memorize, if you want to memorize them, that is. You just change the negative pth roots to a positive pth root, and you're good. And that's it! Unit squircle, so cool. See you in the next one. BAM!